Here's an example which I think really demonstrates the power of composition of functions. Given the surface area of a spherical balloon, so this is just always true. This is not specific to this example. The surface area of a sphere is given to us as a function of the radius of the sphere. So how big is the sphere? And it's equal to 4 times pi times the square of the radius. Right? It makes sense that it's radius squared because it's surface area. It's an area. Okay. So we have the surface area of the sphere dependent upon the radius. So I can map the radius to surface area using this equation. Now, as we inflate the balloon, the radius changes. That makes sense. With blowing air into the balloon is getting bigger, and the radius is increasing according to this equation. So as time moves on, the radius is growing, right? 2/3 t cubed. Right? We know what that function looks like. It looks like this. So this is the part that we care about because time is moving forward. So the radius is getting bigger, and it looks like that. But this provides a map between the radius, between time and the radius. So now we can ask this question. Let's write the surface area as a function of time. So we're going to link together these two functions. We're going to start with time, map it to the radius, and then map that to the surface area. So the surface area, actually, let me write that in this exact same order. We're going to take time, map it underneath the radius function, and get a radius. And then we're going to take that and map it underneath the surface area equation and get a surface area. So let's do r of t first. R of t is 2/3 t cubed. And this is only going to work for positive time values, right? Because we can't go backwards in time. All right. And s of 2/3 t cubed. Let's figure out what that is. S of 2/3 t cubed will be 4 pi 2/3 t cubed squared. So 4 pi 2/3 t cubed. Okay, so let's simplify this a little bit. We've got that 4 pi. The square is going to hit the 2/3 and give us 4/9. The square is also going to hit the t cubed and give us t to the 6. And let's simplify a little bit. 4 times 4 is 16. We have a pi. We divide by 9. We multiply by t to the 6th. So now you have a relationship between time and the surface area of the balloon.